Alright guys, so in this video I'm going to show another quadratic formula I recently discovered and the idea behind it, and actually it makes solving quadratic problems a whole lot easier. So let's look at a quadratic. Let's take an example. Let's say I take this parabola right here. And when you solve the quadratic formula, you are getting the zeros, which are I'm going to call R and S. So what we know about R and S is if I drop a line going straight down the middle, if this is the vertex, let's say we'll call it V for vertex, and it is in the middle of R and S, right? So we know M is nothing more than R plus S divided by 2, right? And we also can say that if the distance out this direction is d, and this direction out would also be d. So what that means is that m plus d, so if I take this point here, which is the middle, I'm calling m, and I add d to it, it would give me s, right? And the same thing is true if I go to the back. If I say m minus d, this would give me r, right? And if it's not clear, think of it in terms of numbers. If this was like 6, and this was 6 plus 2, then this would give me 8, and then 6 minus 2 would give me 4, right? And you go in reverse. You could say 4 plus 2 would put me back at 6, and 8 minus 2 would put me back at 6. So that makes sense. Let me get rid of these numbers here. Okay, so we have that there, and what I want you to realize is that another way of thinking about all of this is if we have x minus r times x minus s, if we multiply this together, we get x squared. Let's just FOIL it out. We'll get minus sx minus rx plus rs. And we can factor out an x here, and we'll get x squared plus negative, well, let me say it this way. We'll get x squared minus s plus rx plus rs, right? Now, it doesn't have to be the case that this has a 1, right? We could technically, this is a special case, that if we have a value on the outside, we'll call it a, right? You could distribute a in here and you would have ax squared, right? But what that means, though, is that because we're talking about the zeros here, right? What I'm showing you here is that we have the quadratic function in standard form. So even if there isn't a value here, if there's a number other than 1 in front, since this thing is equal to 0, you can always divide through by a, and you would create this scenario. So it's not incredibly important to know that to have an a value, whether we have an a value in front or not, whether it's 1 or not, we can create the 1 effect, right, just by dividing through. Okay, so this is, in essence, this is what x squared plus bx plus c is actually saying, right? I can actually even put a plus negative, right? This is what it means. B is negative s plus r, and c is rs. Okay, so why is this significant? Well, this is significant because with this information, if I know that b is negative s plus r, and I know c is rs, and we have this relationship right here, right? Well, then that means that m is actually equal to, now keep in mind that negative s plus r is b, right? So that means that if it's r plus s divided by 2, then if negative b over 2 is m. Think about it. what I'm saying here is b is defined as negative r plus s. So if I divide through by -1, negative b equals r plus s. So we now know that m is negative b over 2. This is incredibly useful because I know what b is, right? We also know that rs is c. But what is r times s? Well, we defined s as m plus d and r as m minus d. So c is equal to, so I'm just looking at this, m plus d, m minus d. So this leaves me with m squared minus d squared is equal to c. Which means if I switch the position of these two, d squared equals m squared minus c. Okay, so you might be thinking to yourself, okay, what does this mean? Well, what do we have here? Well, let's rehash this. So we know that m, I got a little more space, cool. I know m is equal to negative b over 2, right? So m is negative b over 2 squared. I can solve for c, and that's going to give me d squared. And I like this because if I can solve for d, right, we know that to find s and r, it's just m plus d, m minus d, right? So if I take my m, which is b, negative b over 2, right? M right here is negative b over 2. Negative b over 2, now if let's simplify this. This is plus or minus square root negative b over 2 squared minus c. But if I add and subtract negative b over 2 squared minus c, this in essence gives me r and s, right? Because m plus d will give me s, m minus r will give me d. M is negative b over 2, and this business is the distance across. Okay, so why is this super useful? Because I'm sure this sounds a little confusing. Well, let's use this formula right here to solve for what are the roots of this. Now this is, we can easily factor this to what? X minus 4, x minus 2. So the roots are going to be 4 and 2. But I want to show you that this formula gives you the roots as well. All I have to do is take negative b, so take negative 6 over 2 plus or minus negative 6 over 2 squared minus 8. And this should give me, I should end up getting 4 and 2. Let's see. So this will give me, negative becomes a positive. So 6 divided by 2 is 3, plus or minus square root. This is, the sign doesn't really matter here because you're squaring it, so it's going to come out positive. This is 3 squared, which is 9. 9 minus 8 is 1. So 3 plus or minus square root 1. So that's just 3 plus 1 and 3 minus 1. So 3 plus 1 is 4. 3 minus 1 is 2. And there's our answer. So you can see that in a situation like this, it still makes sense. If you can factor it quickly, go ahead and factor it. But you do see how this formula right here is way easier than the quadratic formula. Okay, so let's do another example. Let's take this example here. Let's say we have 2x squared minus 5x plus 4 equals 0. Now, this isn't going to factor out nicely. I don't think so. So what I want to do is I'm going to use this formula. Now remember, in order to use this formula, what has to occur is that the leading coefficient has to be 1. So I have to start off by dividing through by 2. So this is going to give me x squared minus 5 over 2x plus 2 equals 0. Okay, so if my formula is negative b over 2, it's going to be negative 5 over 2 all over 2 plus or minus square root negative 5 over 2 squared minus 2. And this cleans up when you have the 2 here, it goes down here. So this is going to be negative 5 over 4 plus or minus square root. This is going to be 5 over 4 squared. Again, negative becomes a positive. It's not really relevant because you're going to square it, so you don't really care what it is. And let's just clean this up. So we get negative 5 over 4 plus or minus square root. This is 25 over 16 minus 2. And we're going to have to create a common denominator, so we'll multiply both top and bottom by 16. And we'll get negative 5 over 4 plus or minus square root 25 minus 32 over 16, which gives me negative 5 over 4 plus or minus square root. This is going to give me negative 7 over 16, which breaks down to negative 5 over 4 plus or minus square root negative 7 over square root 16, which would become negative 5 over 4 plus or minus I square root 7. Remember, we take the square root of a negative number, an I goes in front, over 4. And let me actually try to squeeze it in, which you could write if you really wanted to, negative 5 plus or minus I square root 7 all over 4. And you have your answer, which is easier than doing the quadratic formula. I also like this method because at the end of the day, if you forget it, you actually can quickly derive it from just this picture right here. So it's kind of a neat little extra other way of doing this. If you already have the quadratic formula, you may not want to memorize this, but it's kind of an interesting idea of how you can play with mathematics and figure out other formulas that actually make your life easier. Because this is by far, once you have this in your head, this formula right here is way easier than the quadratic formula. So, any case, something to ponder. Hopefully you found this interesting. I did not come up with this idea myself. This actually came from a website, a YouTuber named 3 Blue 1 Brown. And I will link to his video, which he has a whole lesson that's like an hour long about this. So his version is a little different than mine. I went straight to B and C, and his explanation is slightly different than mine, but it's essentially the same idea. So hopefully you find this interesting, and I'll see you guys in the next math video.